Topic 4-4, more parallel lines in algebra. We're going to do 4 more examples. You can reference this in our Holt book with Chapter 3, Section 2, pages 155 through 169. Okay, it's good to get a highlighter and highlight our transversals. So I'm going to go ahead and do that for both of these. If these arrows denote my parallel lines, then the transversal that cuts it is this one right here. Same thing with 2. Example 2, these two denote the parallel lines, so the transversal is this line right here. Now, some students get confused with interior and exterior. We've been shading that on previous ones, so if it helps, between the two parallel, shade in with one color and make that an I. Interior, you can even spell it INT. If this helps, do the shading. And for the exterior, the 1 and the 8 are on the outside and the 4 and the 5 are on the outside. These would be my exterior. The exterior. So you're having to determine, to figure out through an algebraic expression some values and finding the measure. What they want for this one is the measure of angle 4. Find the value of x and then the value of this right here. So if this is the one they want, you might want to highlight that too. Okay, so if the measure of angle 1 is this 7x minus 3 and 5 is 8x minus 19, well, let's just look at 1 and 5. 1 and 5 are in my green shaded areas. They hop over the transversal, so they're alternate exterior angles. Those two angles are congruent to each other. So you can show that. This angle 1 is congruent to angle 5. So first let's solve for x. You've got 7x minus 3 is equal to 8x minus 19. Subtract a 7x on both sides. The 7x's go away. You're left with a negative 3 is equal to x minus 19. You're going to add 19 on both sides so that now x is equal to 16. But we're not finished there. You can go ahead and put 16 for x, but we want the measure of angle 4. So there's quite a few things we've got to do here. If the measure of angle 5, sometimes it's good to label it where that angle measurement is. You want to then take your 16 and plug it back in. And you're going to have to find out what the measure of angle 5 is, and then we can say that this forms a linear pair. So let's just do this in our calculator. I haven't used a calculator yet. Instead of writing it out. If you've got 8 and you multiply that times the 16, seems a little distorted, hard to see. Oh well. 8 times 16 and subtract the 19, you're going to get 109. So the measure of angle 5, I'm going to put it back up here even, is 109 degrees. So if you were to now look at this being 109 and 4 we want to know, you're just going to take 180 and subtract it from the 109. And 180 degrees subtract 109 degrees is going to give you 71 degrees. So your angle is 71 degrees. You can always double check it and add these back together. Make sure that they equal 180. Please don't forget the step of plugging in when you're asked to find the measure of an angle. If you want to make a note, you've got to plug your number back in. You got to plug in the 16 for the x, multiply, I should show that down here, 8 times the 16 minus the 19 gave us the 109. Now 109 wasn't one of my answers, but I had to use 109 knowing that this forms a linear pair. That makes a straight line, angle 4 and 5. So adding the 109 plus the 71 is going to get me to 180 straight line. So these are like puzzles. You're having to kind of work around what you do know and what you can determine knowing something is a line. Okay, let's look at number 2. If the measure of angle 4, I might want to put that here, is 20x plus 3, and the measure of angle 6, which we can't say those are congruent to each other, we'll denote what it is in just a minute, is 9x plus 3, what do you see? They did not cross over the transversal. So they are same side interior angles, which equal 180. They're supplementary angles. So if you're going to set them equal to 180 degrees, we can just start adding like terms. You've got 29 x's and 6, because 3 and 3 is 6. Here's your algebraic expression. From here, you're going to subtract 6 on both sides. You still have the 29x, cross that out, is equal to now 174. Divide by 29 on both sides, and your x is equal to, I think this ends up being 6. Okay, so x is 6. It's not a degree. What is it that they're wanting us to find? Let's mark that. They're wanting angle 3. This is the one they're asking for. Well, we can do this one very similarly to the one up there, because we know, I'll cover that up, that angle 4, 3 and 4 make up a linear pair. So if this one and this one are to equal 180, let's find out what the measure of angle 4 is and subtract it from 180 to get the measure of angle 3. So to do that, we're going to remember that we take this 6 and plug it back in right there. And saying that 6 times the 20, you know, you could do it two ways. We could have actually put it into, let's do this. If you put it into this one, what do you know about 6 and 3? We can mark those as congruent to one another. That way we would not have to subtract from 180 and make a linear pair. Why did I put that in pencil? Instead of going to the 120, the 20, multiplying it in there, add that 6 to this x, because once we get this degree measure, sometimes they denote it like, well, they actually did over here. It shows it in parentheses with a degree. That once you plug in a 6, multiply it by 9, you get 54. You're going to add 3 to that, and that gives you 57. So instead of having to subtract anything from 180, you now have the answer to angle 3. Angle 3 is 57 degrees. Why? Because of alternate interior angles. If it helps to do the coloring, do so. These are your two parallel lines noted by the arrows. If you want to make them bigger, you can do that. And then you could shade this one color and shade the outside another color so that you can tell that those two are actually equal to each other. Notice how I marked it. 2 lines, 2 lines. The reason is this one already had 1 line. Showing congruency, you want to make different kinds of markings for the different congruencies. Okay, example 3. We're getting more and more into some different puzzles. Notice that there are 2 transversals. If these are my parallel lines, then I actually have 2 transversals. one that's going to go through here, and then I have another one going this direction. If we want to mark both of them now that we have our highlighter, these show parallel to the two marked here. This shows parallel to there. Two sets of parallel lines make up a parallelogram. There are some theorems that go along with that as well. But there's my transversal. Okay, let's look at the measure of angle 3. They're giving to you as 8x plus 3. The measure of angle 4 is 20y minus 3. The measure of angle 7 is 11x minus 12. If you want to put these in parentheses showing that that full equation has to be performed first before you get a degree measure, you can do it that way. Okay, so there's several things they're wanting us to do. First, they want us, well, actually here they just want values. We're not going to have to, well, we might end up having to plug some things back in. But let's look at something that we can state as congruent. Again, where's our interior and our exterior? These are on the inside. Any angles up here would be on the outside. But notice how everything in this whole diagram is, everything's on the inside. So angle 3, don't try to make that a 33, and angle 7 are what? Alternate interior angles. Therefore, they are congruent to each other. When you work out 8x plus 3 is equal to 11x minus 12, working through the algebra. If you need help with that, come see me. I'm just going to go ahead and just give some answers to these. That one's going to be, once you've worked that out, the answer is going to be x is equal to 5. There is another way that I can show you to, we've done lots of algebra. There are some tricks with the graphing calculator. You can put that, if it's a single variable equation, this could be entered into y1, this can be entered into y2. You can use the second calc. It's on top of the trace button. Second calc. I'll just go ahead and write the word trace right here. Find the intersection, which is number 5. And it will actually give you a value of x and a value of y. You don't need your y value because you're only solving for one variable. So this is what you'd be looking for right here. If you want some explanation about how to skip some of the algebra, and let me show you this, come see me if you haven't already learned that. So your x value would be 5. If you're going to plug it back in, we do know that several things. This makes up a linear pair going this direction. I'll cover that up and show that. And also these two are same side interior angles, so they would actually equal 180 degrees too. So right now you're looking at setting up a problem equal to 180 degrees. But if you want to go ahead and solve for angle 7, we do know that x is 5, so plugging in 11 times the 5, subtracting the 12, that would give us 43. So if this is 43, you would subtract 43 from 180, and it would leave you with 137. So that angle has to be 137. And again, if I've gone a little bit too fast, just remember, and I'll leave this here to look at, that you have plugged in your x right here, multiplied it by 11, and subtracted 12 to get 43. Knowing that 43 is angle 7, we can get the measure of angle 4 by subtracting from 180. So what y is, we could say 20y minus 3 is equal to the 137. And add 3 to both sides. And you've got 20y is equal to 140. Divide 20 on both sides, and you would get 7. 140 divided by 20. 7. So go ahead and fill in your x and y values, 5 and 7. Okay, last example. Make sure you feel you really understand these before you start the exercises in the worksheets that follow. Okay, if this is our transversal, we know several things. Parallel lines cut by transversal, alternate interior. Notice all these are on the inside. So angle 2 and 5 would be congruent to each other. Denote that with one line. 6 and 3 are congruent to each other. We'll denote that with 2 lines. They're giving you all these different expressions and telling you what answers are. So let's just plug those in. I've got 4 is 97 degrees. That's the one they've given you the whole thing. Angle 2 is 6y plus 5. Angle 3 is 5x minus 16. Angle 4, they gave it to us. Angle 5 is 12z minus 1. And angle 6 is 3x. There's lots to find values for, but the only one, notice if these alternate interiors are the same, they have 2 variables. You're not going to start with ones that have 2 variables. You would start with one that has 1. Try the same trick in example 3 by plugging it into your calculator if you'd like. 3x is equal to 5x minus 16. However, this one's not having to do 2 different things, constants and coefficients, so it might not be feasible to do the y1, y2 calculator trick. But if you do this one with that, you should get that the x is equal to 8. So plugging in 8, 8 times 5 is 40. And 40 minus the 16 is equal to 24. So if you've got, let's see, this is 24, and this is 24, then we know what, well, 3 times 8 is 24, so we know that these two are 24. If this is 97 and this is 24, remember how I told you that all this angle and this whole angle would be same side interiors, and so that would equal to 180. So you actually have the 97 plus the 24 plus the unknown angle, the measure of angle 2 along with it would all equal 180. And so this is the one we don't know. We're not sure what angle 2 is, but once we find that, we can solve for y. And once we solve for y, we would know what z is. It's a puzzle. All right, so this is going to be 97 plus the 24 is going to give you 121. 121 plus what we don't know, angle 2, is equal to 180. Subtract that from subtract that, and you're going to get that this measure of angle 2, the measure of angle 2, is going to be equal to 59. So using that, you would just state 59 is equal to 6y plus 5. And working that out, you'll get y is 9. And if the whole thing is supposed to be equal to 59, you can say 12z minus 1 is equal to 59. And then you would get z is equal to 5. And that concludes 4-4.